Okay, so welcome everybody to this presentation sponsored by WISE, one of our seminars. I'm Claudio Canizares. I'm the new Executive Director of WISE. Today we have the pleasure of having a legal list from the ISO making a presentation on integration of distributed energy resources in markets. Particularly from the perspective of distribution markets. It's an area in which he's been working on very closely, and certainly a very timely, topical, and relevant topic nowadays. Ali has worked on the ISO, Independent Electricity System Operator, and his previous organization in terms of planning, the Ontario Power Authority, in various roles since 2009. He's been part of the design and implementation of various provincial electricity resource procurements, focusing on distributed energy resources, DERs, and power purchase agreements, PPAs. He's currently working on the development of local electricity markets, which is the topic of this presentation, in a demonstration project with NRCan, Natural Resources Canada, and Electra Utilities. He received a Bachelor of Applied Science in Mechanical Engineering and completed a graduate diploma in Electric Power Engineering from our program at University of Waterloo. And he also holds a Master Business Administration, MBA, from the Rodman School of Management. Without further ado, Ali, please, the floor is yours. And thank you.
Thank you very much, Professor Canizares, for that introduction. And thank you, everyone, for your time and interest today. So as Professor Canizares mentioned, the topic for the presentation today is DR integration. And I'm going to sort of start off discussing the topic at the transmission level in wholesale markets, and then going to get into the distribution level, and then speaking to that in a manner that's consistent with sort of deregulation and having independent third-party providers of DER that are participating in the market and providing services to the distribution level. Before getting into it, I just wanted to mention that I do work in the innovation and R&D team at the ISO, and so these topics that I'm going to speak to is very much sort of the focus of my work on a day-to-day basis. And I also wanted to as Professor Canizares mentioned, I am a Waterloo alumni, and I just wanted to note that our organization, the ISO, has quite a few number of Waterloo graduates, especially from the master's and PhD programs. So just wanted to do a bit of a plug, for students that are tuning into this. If you are interested in this type of work or the work that the ISO does, we're always hiring. So with that said, let's get into the presentation here. So first off, a little bit about the ISO, who we are and what we do. So the ISO, we operate the transmission level, the bulk system here in Ontario, balancing supply and demand and getting other reliability services from market participants. So we do run the wholesale market here in Ontario. We also plan. We do bulk system and regional planning for the province. We also run conservation programs for the province, and not just conservation. Historically, we've done other types of programs as well. I'm going to speak a little bit about the advancements of DER here in Ontario, quite a bit actually throughout this presentation. I'll note a few of the programs that we've run in the past. The ISO being an independent entity and dealing with market participants and other stakeholders, engagement is very central to what we do. So we work closely with our various stakeholders to make sure that we're transparent and our work is helpful to stakeholders. And then finally, we also support innovation, and that's the team that I'm from. Wanted to give you a sense of where we're going over the next hour. So I'm going to start off with some introduction for folks that aren't familiar with DER and the conversation we're going to get into. Then going to again speak to the wholesale integration of DER, speak to distribution level integration, and then speak to the interaction, the boundary between the wholesale market and distribution market. And then wrap up the discussion with some research gaps and any questions or discussion from the audience as well. So first off, in terms of a definition of DER, so on this slide here in the blue box, that's the ISO's definition. And there's quite a few definitions floating around out there. Many different organizations are starting to define and refine their definitions as well. And so the ISO's definition captured on the slide. First, with respect to DER, it's only resources that are distribution connected and that we refer to as DER. And that doesn't need to be directly connected. It could be directly connected to the distribution system, but it could also be indirectly connected to the distribution system, meaning that the DER could be behind a load customer's meter and then potentially participate as demand response, or maybe in the future in more sort of sophisticated ways. But regardless, DER, in accordance with our definition, they must be distribution connected. Our definition also speaks to the resource producing energy, storing energy, and controlling load. So that sort of captures generation resources, storage resources, and also demand response resources. So that's sort of the ISO's definition. I've also included FERC's definition on this slide. So FERC is a US federal agency that regulates the interstate transmission of electricity and wholesale sale of electricity. And generally in the US, they promote the voluntary formation of transmission organization, regional transmission organizations, RTOs, as well as independent system operators, ISOs. Much like the IESO here in Ontario, our organization, but of course FERC is only an American entity and sort of applies to the American ISOs and RTOs. But regardless, it's something we very closely follow FERC's work, because it's very relevant to our organization as well. So FERC similarly defines this DER as being distribution connected. And they've listed a number of examples in their definition. And I just wanted to point out the fact that FERC includes energy efficiency as a DER, which may be slightly different from the ISO's definition. We talk about controlling load, so that suggests that there's sort of a dynamic control of the DER. Energy efficiency is usually sort of considered to be a structural or a sort of permanent, sustained change in consumption. So it's not really a controllable thing. But regardless, this is part of the conversation around the definitions of DER. And I also wanted to note that the OEB, the Ontario Energy Board here in Ontario, is also going to be putting out a working definition of DER. And our organization, the ISO, as well as others, I'm sure, are paying attention to that process too. And so we're looking forward to seeing what the OEB will, or how the OEB will be defining DER. So that's just to make sure that we're all on the same page in terms of what we're talking about. And then I wanted to very quickly just speak to, now that we know what DER are, or how we define DER, speak to why DER are relevant and important, and why they may be a good idea to integrate. So the material on this slide come from material from an article from an MIT team. So it's in the IEEE Power and Energy magazine, a recent article. Just going to walk you through this and also add a few of my own thoughts. So generally, DER can provide the same services as centralized resources. And by centralized resources, I mean resources that are connected at the transmission level. And so, if you think about, say, solar photovoltaics, solar PV, that could could be grid scale and connected to the distribution system or the transmission system, so a large solar facility, or it could be a smaller solar facility, rooftop solar, for instance. But regardless, either one of those largely can provide the same services, and then similarly, small modular storage can largely provide the same services that a large storage facility, a grid scale storage facility could. So that's one thought for you. And I wanted to note that generally with larger resources, there's economies of scale, which DER being smaller do not have that benefit. However, DER being small and modular have added value. They have locational value, which is not accessible to larger facilities. And that's sort of one of the key things about DER and why they may win, so-called win, or be the more economically efficient type of resource in some circumstances. Not all circumstances, but some circumstances. And I'm going to sort of explore what those circumstances are. Yes, so a big part of what DER, the value that DER can provide has to do with non-wires alternatives. And what I mean by that is that instead of building new transmission and distribution infrastructure, such as lines and stations, DER can be used. And that allows the planners, the distributor or the transmitter to leverage the DER as opposed to building that or investing in new network infrastructure, and potentially push back that investment, push it back, or in some cases even fully avoid that investment. And one of the dynamics of that has to do with the chunkiness of larger resources over larger infrastructure. So if the distribution network, for instance, is at its limits and new distribution assets need to be installed, those are typically large pieces of infrastructure. But with DER, given the fact that they're, again, small and modular and can be sited in a targeted manner in areas where there is need, or even over time, it can sort of slowly be deployed. You can, again, instead of a big chunky investment, do some small DER. And when you sort of look at the economics of that, that is one of the areas where DER could be beneficial. DER has other benefits as well. There's loss reduction. And in conversations, oftentimes people note that, well, that loss reduction isn't really that material, but I beg to differ. And I'm looking forward to seeing more sort of data around this. At the lower voltage levels of the distribution level, that means that the losses are higher. Also, when there's peak demand, that also means that losses are higher. And peak demand is generally, or one of the cases where we would look to use DER. And then finally, with respect to losses, there's sort of average losses of the system, but there's also marginal losses, and marginal losses will be higher. So when we are looking at using DER sort of as an incremental resource to bring down peak demand, one way to think about that is that it's actually reducing the losses at the marginal rate and not at the average rate. And again, that is potentially higher. So there's some value to the loss reduction. There's, of course, value with respect to improving reliability and resiliency as well. And I'm not going to talk a lot about that particular topic, reliability and resilience, in this presentation, but I'll just note that this is one of the other areas where there could be material value to DER. And then just one other thought with respect to the value of DER. One of the more challenging components of the value, to put a number on, is what I refer to as the option value that DER provides. So, so one way that you could use DER is that if there is an expectation of load growth of new customers connecting, but that's not necessarily firm. So it may materialize, may not materialize. What a planner could do is decide that, as opposed to making a big long-term investment in network infrastructure, they can install or secure services from DER for a number of years to just see how things play out, whether that load that they were expecting, that load growth, actually materializes before the planner fully commits to that chunky, long-lived infrastructure. So that's another way of thinking about DER as well. And so the big idea here on the slide is just with respect to that economies of scale and whether it makes sense to take advantage of the locational value of DER or the economies of scale of centralized generation. And I wanted to show a few diagrams again from the MIT team that I mentioned. And so this diagram here shows both solar and batteries, the two diagrams here, and how the cost changes with size. And so you'll note that the for solar PV figure, so it's figure 3 on the slide here, for utility scale solar PV, that's approximately half the cost of residential scale PV. And then similarly, with respect to battery storage, lithium-ion battery storage, you'll note that the residential cost is maybe 2.5 times, I'm just eyeballing it here, 2.5 times more than the utility scale cost. And then one more quick diagram from, again, the MIT team. So this diagram shows the value of DER on the left-hand side. And you'll note that sort of the first bar has to do with the transmission level or system level value. The second one has to do with losses, and you'll note that that's, it's small, but it's still material. And then the third piece there, network investment deferral, that's the non-wires bit that I was referring to. And you'll see here that that portion of the value is key because it's quite material. On the right-hand side, it's noted that the cost of the DER is noted, and so both a smaller system, but also utility scale system. And you'll see that the value of DER falls somewhere in between those, the cost of large and small. And so one of the key ideas here is that locational value versus economies of scale needs to be balanced. And we need to have the appropriate planning assessments and market mechanisms to hit the sweet spot, if you will. And one of my general thoughts is that, if the economics of the system were such that, central resources and building more network infrastructure, transmission distribution was clearly the better, cheaper way of going about things, things would be easy. On the other hand, if going off grid or building microgrids was sort of the economic way of going about things, it would be easy. What's really challenging is that the economics probably suggest that somewhere in between is the most economically efficient point. So that's another.
Ali,
yes.
Sorry for the interruption. And to make it a bit more dynamic, and
yes,
this is a bit online stuff tends to be a bit dry.
yes.
Just to move things along a little bit and also help with the questions. I wanted to ask you a question here, if you don't mind. Sorry for the interruption again. It's not the usual thing we do, but anyway.
Yeah.
Since there's a small audience, I'm curious about the reliability value. I thought it would be high. Why would it be 0?
I mean, that's a very good question, Claudio. And
because if I may, one of the reasons for theirs is precisely increase.
Yes.
Increase, although this is the utility view or this is the customer view?
So this would be the utility view, and it's a good question, Claudio. And I would have to go digging through their article to see how they justify that. I would have expected to see a reliability number there as well. It's my own sense of it, and I would be very curious to hear your thoughts and other people's thoughts as well, is that it's a rather difficult number to come up with. So maybe that's where they're coming from.
From the perspective of the ISO,
Yes.
or the perspective, well, I guess the planning perspective, I presume you see value on having theirs for resiliency, right?
Or so yes. So generally, I would say, Professor Canizares, yes. I mean, the ISO, as you know, we're focused on the transmission level, and less so on the distribution level. So from our perspective, resiliency, and correct me if I'm wrong, but resilience is usually about bringing the customers back online after an outage or an event, or something like that.
Okay.
So from a transmission level perspective, if distribution customers have DER and can isolate and have services, maybe as part of a microgrid or something like that at the distribution level, that's not something that we would put a dollar figure on. That would be something for the distribution companies and the OEB to figure out. From my own personal,
I wonder whether that's the perspective they take here. Yeah, that's a good point.
Cool. But I'll just generally note, Professor, that like when it comes to resiliency, that's not necessarily an area that I'm sort of a subject matter expert in. So there will be other people in the organization that would be able to speak to that.
Thank you. Thanks. So, sorry for the interruption.
No problem at all. So with that, I'm gonna move forward. So now that we've talked about what DER are and where they may make sense, just wanted to get into how we could potentially implement or operationalize DER in the system as well. And so this material here comes from a report, Rocky Mountain Institute. It's a think tank, and they sort of spelled out or detailed that there's different approaches, different categories of approaches. So there's programs that you could use to incentivize DER installation and operation of DER. And that refers to offerings that the utility would provide, say incentives for energy efficiency or behind the meter batteries or something of that variety. So there would be programs, and I'm going to provide an example or two of that in the next few slides. There's pricing mechanisms or tariffs or rate structures that incentivize, again, DER deployment and operations, such as time of use rates, critical peak pricing, or even net metering could fall into this category. And we do have net metering here in Ontario. I'm going to very quickly give you a summary of that. And then thirdly, there's competitive processes. And this is the area that I'm going to spend a fair bit of time on. And that could be auctions or RFPs. And so, yeah, so that's generally what those three terms refer to: pricing programs and procurements. There's different considerations for why you may choose one over the other. Maybe just in the interest of time, I won't get into that, but I will be focusing on the third approach here. But before doing so, just very quickly, wanted to note that in Ontario, we've for a number of years had the Feedin, Tariff, and MicroFIT programs. So those are programs. So launched in 2009 for the MicroFIT being for smaller resources, less than 10 kilowatts, and the Feedin Tariff being for larger resources. But these programs are retired at this point, but they were quite successful in resulting in deployment of DER. So there's a chart here indicating that we ended up procuring more than 4,000 megawatts of DER through these programs, and there's tens of thousands of contracts that the ISO holds. So we deal with tens of thousands of contract counterparties, and yeah, so that's one of the programs here in Ontario. We also, as I mentioned, have net metering, and this has been around for quite a while. So net metering has to do with it's a billing arrangement where customers who have renewable energy on site can use that for themselves and not pay utility rates, but they can also, if there's excess DER output, they can feed that into the grid and get bill credits that they can use later on to offset their future bills, or that month, or even future bills. And there's been some evolution of the net metering program here in Ontario over the past several years. So In 2017, there was an amendment such that customers can also pair storage with the renewable facilities. And very, very recently, last year, the Ministry of Energy here in Ontario has also proposed amendments to the net metering regulation to also do some demonstrations for community net metering, meaning that the DER doesn't necessarily need to be behind a load customer's meter for them to receive the benefits of net metering. It could be elsewhere, but but regardless, they have access to that billing arrangement, the net metering billing arrangement. Another quick program, or if you will, a pricing sort of mechanism here in Ontario, the ICI program, the Industrial Conservation Initiative. So this is effectively a demand charge, and there is a material cost here in Ontario, global adjustment, that gets applied to larger customers called Class A customers here in Ontario. And so it's applied to them based on the percentage contribution to peak demand. So we look at five peak hours of the year, and then we proportionally allocate the cost of global adjustment to customers based on how much consumption they had in those 5 peak hours. And this too has the incentive or the cost that can be avoided as part of ICI is quite material, and this too has resulted in a fair number of behind the meter DER being deployed here in Ontario.
I have a question again,
Yes.
Ali. Sorry for interruption. Regarding your last question, you have a sense of how big that this has been in terms of power? How much theirs have been deployed based on these global adjustment?
So that's a really good question, Professor. So certain things the ISO has quite a lot of visibility into, other things less so. And so this is one of the areas where we have less visibility, but we have some sense of what this is. It's in the order of 1,000 megawatts, something in that range, maybe even more. It's hard to really put a number on it, but something in that range.
But that's significant. Okay.
It's quite significant, yes.
I'm just asking this because we did a study for an industrial customer, and it made a lot of sense. So I presume
Yes.
people are just doing it. Okay.
Yes.
Mostly
Yes.
industrials, eh?
So the definition of Class A, I mean, depends on what industry you're in, but it's above 0.5 megawatt. So that automatically means that it's going to be sort of commercial and industrial customers.
And do you know if the net metering has had any impact at the residential?
So that's another sort of area that we would have a little bit less visibility. So generally, and this is one of the sort of the benefits of programs and procurements and markets, is that we know who we're dealing with, but some of these sort of arrangements we have less visibility into, and net metering would be one of those, unfortunately. Professor, I just want to also circle back to ICI and just clarify that the 1,000 megawatts that I was loosely referring to, that's the potential reduction that we would see. So that could be demand response, not necessarily resources behind the meter. It could just be load curtailment, where people shut down their widget manufacturing facility or whatever that is.
All right, thank you.
Of course. Can't believe that's already been half an hour. I have so much material to go through here. So the ISO, we just recently started developing a DR roadmap, and we're going to be laying out the ISO's objectives, initiatives, and timing to integrate DER into our wholesale market. We just started this engagement. We had a webinar in June, and there's another one coming up in October. The actual date hasn't been settled yet. And we have 3 focus areas that we've identified. So we are looking at wholesale market integration of DER. We have a lot of interest in non-wires alternatives. And again, with respect to sort of the boundary between the distribution system and what we manage, transmission system. And all this material is online, so folks can take a look at that. And I'm going to structure the remainder of this talk around these 3 areas. So first, wholesale market integration. And so generally to give you a sense of where we are, we chatted about why DER, the 3 Ps, pricing, procurement, and programs, give you a sense of the DER roadmap, and now we're going to get into wholesale market integration. So FERC order 2222, this is an order that came out relatively recently, and so FERC in the US is seeking to enable DER aggregations. Aggregations of DER, many DER that come together as part of an aggregation to compete in all of the organized wholesale markets in the US. And the intent of this is to empower new technologies, make sure that, from a sort of market perspective, that DER is participating on a level playing field, just like larger facilities. They're looking to just generally enhance competition, encourage innovation, and then ultimately to drive down costs for customers. So FERC, who regulates ISO RTOs, had a deadline of July 19 for the various ISO RTOs to submit how they're going to be integrating DR into their markets. NISO and CAISO, so the New York ISO and the California ISO, they already had FERC approved what we would call participation models for DER, and they needed to make a few refinements to that, and they submitted their filings on time. Other ISO RTOs have asked for extensions. I'm going to very quickly sort of summarize what the FERC order talks about, and then show you how New York and California are approaching this. So the FERC requires ISO RTOs to introduce DER aggregations or aggregators as a market participant in all of their various markets, or the different services they have. They also specify that participation model needs to be appropriate for DR aggregations, considering their operational characteristics. Very importantly, they specified a minimum size threshold of 100 kilowatts. So the aggregation needs to aggregate up to 100 kilowatts for it to then be able to participate in the wholesale market. And just to give you a sense of where Ontario sits on that right now, the minimum size threshold in our market is 1 megawatt. So this is 1/10 of that. They also want the ISO RTOs to capture sort of locational requirements. I'm going to speak to this a little bit, in particular distribution factors, and maybe just give you a sense of what that is. So an aggregation could be below one transmission node, or potentially the aggregation could span several transmission nodes. So if it spans several transmission nodes, distribution factors are intended to indicate how that aggregation is spread across those many nodes. And then, of course, there's data requirements, metering and telemetry requirements that need to be specified. And then, very importantly, the coordination between all the various parties that are involved, including the distribution company. And then the final thought here is that so the aggregation needs to be something that can be updated. So over time, if there's sort of contributor DER to the aggregation that are not participating anymore, whatever that case may be, the aggregator should be able to sort of update that aggregation and continue to participate. I very quickly wanted to give you a sense of where California and New York are on this. So this is a chart that I lifted from an EPRI presentation, and we're part of EPRI working groups on these topics. I'm just going to very quickly just fly through this. So this summarizes the NISO and CAISO participation models before they submitted their most recent filing to FERC. So this reflects their participation models prior to FERC Order 2222. So you'll note that the table here specifies the various markets and services that they can that the DER aggregations are eligible in. It indicates that minimum size threshold, and you'll see that New York ISO had the 100 kilowatts, so they didn't need to do anything for the FERC order with respect to that. But then CAISO has some other numbers there that presumably were updated in their most recent filing, and so they indicate what type of resources can participate where, in which one of their services, and again, with respect to locational requirements. So you'll see that NISO has specified that the aggregation needs to be below a one transmission node or pricing node, as they refer to it, while CAISO has multi-node aggregations enabled. And there's a range of issues that you need to get into with respect to multi-node aggregations. For instance, if you have LMP for each one of the transmission nodes, how do you settle the multi-node aggregation? Dual participation refers to if a DER or DER aggregation can provide services both to the distribution level and the transmission level. So there's got to be rules around that, and I'm going to spend a little bit of time on what that involves as well. And New York and CAISO, of course, had to address that issue as part of their findings. Again, meter and telemetry requirements, so they have those as well. And then the final row here is EPRI's sort of sense of the items that New York and California need to update to make sure that their participation model is good for the FERC Order 2222. So that's a quick run through of New York and CAISO's participation models. I just wanted to note that here in Ontario, we're doing similar work. So this is from a white paper that our team actually put out over the past year or so. So this just summarizes, we basically went through the different markets and services that the ISO has, and then indicate here on this chart, this is a summary chart, which resources are enabled for what services. And there's two actually white papers that go into quite a bit of depth around this. And we put out these white papers recently, and now we're also initiating what we're calling a market vision project. So this is going to lay out a high level sort of considerations or options for how the ISO could integrate DER into our wholesale market, very similar to the issues that we just spoke to with respect to FERC and New York and California markets. Creating so distribution markets. So switching gears a little bit, so we spoke to wholesale market integration, gave you a sense of the FERC order, New York and California, spoke to Ontario, and now switching gears to distribution markets. So this chart here is again from EPRI material. So EPRI has a few examples here of potential distribution level services. So the first one, distribution capacity, that's really about non-wires. So not building, so instead of building network infrastructure, distribution assets using DER to meet needs. And then voltage support, they indicate that voltage support could be a distribution level service as well. And then they have, to your point, Professor Canizares, they have a couple of services that relate to reliability and resiliency, which again are very important, but unfortunately I'm not an expert on those. So I just wanted to expand a little bit on non-wires very quickly here, walk you through a few diagrams and indicate just generally how at least I think about non-wires. So I'm just going to walk you through the three diagrams. Diagram A, so this is a very, very basic system, the least number of elements to really get the concepts across. So what this is indicating is that there's a 150 megawatt large transmission connected generator. So you can loosely think of that as all the transmission connected resources. There's the TD interface, transmission distribution interface. There's a station, and then there's load on the distribution side. So in A, everything is at its limits. So this is just notional. Everything is at its limits. So if there's any bit of load growth, that necessitates infrastructure investments and installations. So in B, the traditional way of doing that is to build more centralized generation, indicated in green on the diagram. And then also build more network infrastructure to deliver that centralized generators output to the load customers at the distribution level. But in C, what you could do instead, and this is again sort of the key thing with respect to DER, I think, is that they're modular, they're small, and they can be targeted and sited close to load. So instead of building the network and centralized generation infrastructure, you could do DER close to load. So DER is in fact competing against centralized generation and network infrastructure at the same time. And so to really enable that, so if you think about that 10 megawatt of DER in C, if you think about that in terms of solar PV, which is a passive resource, doesn't need a lot of effort to sort of manage that. that's fine. But as soon as we get into battery storage, EVs, demand response, and smart thermostats and other dispatchable responsive resources, somebody needs to manage that. And the ISO, we don't have visibility into the distribution system. We don't model it. We don't know if there's any problems, constraints, anything at the distribution level. So then you need a distribution system operator, something similar to the ISO at the distribution level, to manage that all of that and make sure that it's being done in a reliable way. So that's the concept there with respect to non-wires. And now I'm going to get into a little bit of a few examples of non-wires. So in New York, they came out with a big policy initiative many years ago. There was quite a bit of interest and excitement around this in 2014. I'm going to fly through this. So what New York did, and this is still ongoing, they're still putting out new initiatives as part of the New York Rev. But so one of the major things they did is introduce a new planning document for the utilities in New York, and also permit non-wires in distribution planning. As well, in track 2, they tackled or addressed the incentives that a distributor would need to pursue non-wires and DER instead of traditional network infrastructure. And then the final bullet on this slide speaks to the value of DER. So what they did in New York is sort of evolve from net metering, which again we have in Ontario, to a slightly different regime where it's not, quite the same concepts in net metering, but they've put a dollar figure, I suppose, to the value of DER. So when you inject into the distribution system, then there's a price that they've established in New York that you would receive. So they replaced net metering with the value DER program. I just wanted to show you a little bit. They're quite progressive in New York, so I wanted to show you. So this is one of their utilities. So they have these GIS, graphical information system information online, and it sort of indicates where in their system DER could potentially be connected, so hosting capacity. They also, in New York, they're not experimenting or demonstrating non-wires, they're fully implemented it at this point. So, so what I'm showing in this slide here is a number of procurements being done by Edison for non-wires in New York. Similarly, in California, there's similar initiatives. So the California Public Utilities Commission has been making great progress over the past several years. So they too have planning documents that they require of the utilities, the distribution resource plans. They also are pursuing quite a few demonstrations and pilot projects. Probably don't need to spend a ton of time on this, but just wanted to give you a sense of what they're up to, and you'll see sort of the progression over the years and how they are getting more sophisticated and more refined in their approach. And then similarly, just like New York, there's a number of projects, just looking at time, I'm not going to speak to this in detail, but there's a number of projects in California as well. So very quickly here, so there's a request for offer, so this would be a procurement approach for non-wires. This is Southern California, Edison, I think is what it says up there. And yeah, so they've just recently, this is 2021 information, so they've recently identified a couple of areas in their system where non-wires would make sense, and they're running a RFP process for that. And then I wanted to give you a sense of what the UK is up to. So again, very progressive. The UK has quite a lot of DER in their system. In 2017, they started a project to sort of transition to distribution system operators. So again, DER and non-wires and all of that sort of active management of the distribution system. They again have this is very. The point I wanted to make here is that it's very similar. I'm going to speak to Australia as well. It's very similar what everybody is doing across the globe with respect to DER and integration of it. Interestingly, in the UK, there's quite a bit of discussion about sort of least regrets pathway. So if you sort of want to evolve your system, there's a number of steps you could potentially take. And the way they're thinking about it is, well, how can we sort of make some progress without prematurely going down a path that we may not be able to return from? So I'm going to show you a few slides as to how they think about that. And then the bullet here is very interesting. There's 2.9 gigawatts, which is hugely material, of what they call flexibility services that they're seeking from DER in 2021. And they're also working on standardizing their approaches to that procurement. And again, like everybody else, they're very focused on the boundary between the transmission and distribution system as well. So just wanted to show you, and there's so much material with respect to this project online, but in the UK, they're thinking about a number of worlds, potential worlds in the future. I'm very quickly going to speak to it. So world A has to do with the DSO, the distribution system operator, sort of coordinating everything at the distribution level. World B is where the distribution system operator and the ISO sort of coordinate together and work together. World C is a price-driven world. So if you recall the 3 Ps, pricing, so a world where the pricing is sort of the main driver of the integration of DER. World D is where the ISO, so the transmission level ISO or system operator, coordinates even at the distribution level. And world E is where there's sort of third-party flexibility coordinators or platform providers, if you will, that are sort of managing all of that. And yeah, in the UK, they're quite sophisticated, done quite a bit of analysis and just showing the various products, and I'm not going to speak to it in detail here, but there's quite a bit of work. And so this is what I meant with respect to sort of those transition paths and least regret pathways. So what they're doing in the UK is World B, which World B is where the DSO and the ISO work together. They see that as being a good way of approaching things in the near term. And then so they envisions maybe around 2030, they'll be in a better position to sort of choose which one of these other pathways that they ultimately want to go down. And that's sort of the least regret approach that they've taken there. I want to show you that sort of these markers are also live. This is just from one of the relevant websites. Again, a GIS sort of system that shows the various parts of the UK. This is around London, I think, where there is a need. And then they have sort of service definitions that they outline as well. And there's timeframes for when participants need to submit offers to participate in that. And then turning attention back to Ontario. So the OAB has a very interesting, exciting initiative going on right now. So the Framework for Energy Innovation. And so they have a working group of sector representatives participating in that. And my boss, actually, Brennan Lowe, is part of that working group. And there's a couple of work streams that they're envisioning, one of them being focused on use cases, in particular non-wires, and then a second work stream that focuses on data that's needed to make all of this work. And the OEB has also indicated that there's other topics that they're going to be tackling further into the future. So they're sort of taking an incremental, flexible approach. So they've indicated what they're interested in exploring right now. And then in the future, they're going to get into some of the other issues as well, including how to incentivize distributors and whether distributors should own the DER or it should be exclusively sort of available to third-party independent participants, and the distributors would not have ownership of DER. So that's one of the topics that the OAB is going to be looking at. I'll skip this slide. I also want to note to folks, and this is not very well known here in Ontario, but there is at least one example of a distributor here in Ontario pursuing non-wires through the regulator, the OAB. So it's again not demonstrations of pilots or something like that, but an actual implementation, and that's Toronto Hydro's local demand response program, where they've identified a few areas here in downtown Toronto, where I'm at right now, where there needs to be capacity relief, and so they're running a program for that. I mean, this is interesting material, but I just, in the interest of time, going to skip through this. And I just wanted to note that, so CCLTS is an actual sort of implementation of Nonwires, but there's a number of demonstrations and pilots here in Ontario as well. And the ISO is as one of the funders of those types of projects, specifically through the Grid Innovation Fund. And just noting here a couple of projects that we're supporting. One of them is from Opus One, where they're doing a transactive energy market, they call it, which includes calculation of DLNP, distribution LNP. And then there's also Power Consumers. It has an interesting project as well, and they're working with Nodes, which is a sort of distribution level platform provider. Switching gears with only 10 minutes left here to transmission distribution coordination. Very quickly, here's a framework around how transmission and distribution coordinate in the future. So this was work done by Lorenzo Christoph, Paul DeMartini, and JD Taft, some well-known names in the space. So this is their model. I'm going to quickly describe it to you. And these are conceptual. So on the so this is a range with two bookends. On the left-hand side, the total ISO model that involves the ISO sort of extending everything, extending its modeling, its markets, its dispatch, everything to the distribution system. Generally, there's concerns around scalability of that. The tools, the software tools don't really exist for the ISOs to do that. And frankly, the approaches to modeling are very different at the distribution level as opposed to the transmission level. So there's a number of sort of considerations there. On the right-hand side of the range, the total DSO, that has to do with the way sort of we would characterize is that DER have one interface in that. So DER only talking to the DSO, and then the DSO sort of acts like a, if you will, an institutional aggregator, and then offers the DER into the wholesale market, and then gets dispatched by the ISO, and then relays that dispatch down to the DER. And in between those two models, there's a bunch of ways you can go about a hybrid DSO. But generally, that has to do with DR having two different pathways, one to the DSO and services from the DSO, and a separate one with the ISO. And so the main way that I think about that is that the DER would come to the DSO specifically for distribution level services, and then would go to the ISO for transmission level services. But again, there's a range of ways that you can slice and dice that. Generally, I would say that with FERC Order 2222, most jurisdictions are gravitating towards a hybrid DSO model. But here in Ontario, actually, the demonstration project that I work on, we're demonstrating a total DSO model. And when we generally talk to folks, at Lawrence, at NREL, for instance, or other people that are sort of focused on further into the future, it's generally a total DSO model that they're envisioning as well. There's a bunch of considerations when it comes to these coordination models. I'm not going to speak to these in detail because we're running out of time. I wanted to note that in Australia, similar to, again, California, New York, here in Ontario, UK, everybody, they're doing similar work. So they too have identified a number of ways that the DSO and the ISO could coordinate and work together. They too are looking at least regret actions. But there's a unique idea that they have in Australia that I haven't seen elsewhere, and that has to do with operating envelopes. And I want to very briefly touch on this. So the concept in Australia that they're developing is that one of the ways that you can sort of coordinate the distribution system with the transmission system is that the AMO, the Australian ISO, the market operator in Australia, would have a platform that would be used both for the wholesale market and also to get information from the distribution level. And so the DER and the utilities, the distributors would go into that platform and indicate operating envelopes. So the DER can be dispatched within a certain envelope, and the distributor has influence over what that envelope is to make sure that the DER is not going to operate in a way that's going to be problematic for the distributor. So that's the concept that they're working on there. And there's a few papers that speak to how those operating envelopes could be determined. I'm not going to get into the details of this. New York similarly has a few interesting ideas around how to coordinate the distribution system with the transmission system. And so and they call it the dual participation model. So what they're focused on is that the New York ISO's dispatch must be followed. And what the bids and offers from the DR participants or the aggregators, what they're submitting into a wholesale market should be reflective of what they're doing for either a host load customer or for the distributor. So if the distributor asks them to do something, the DER needs to capture that and reflect it in its bids and offers into the wholesale market, so that New York ISO has some visibility into what the DER is doing as well. And there's a lot of discussions, and this is a very sort of rich area to my mind, around sort of conflicting instructions, who has priority over the DER. Is there going to be operational double counting, where both entities think that they're using the DER, but it's actually only helping one of them? Is there double compensation? There's a range of issues and considerations around what that coordination would look like. And I'm going to close with very quickly just noting that this is the space that our demonstration project is focused on as well. So this is the project that I work on. I'm going to very quickly summarize it. So basically, again, we're looking at the total DSO model. So where the DER come to the distributor only. In our project, Electro Utilities here in Ontario is acting as the DSO. It's also acting as an independent DSO, meaning that it's not participating in its own market, Electro Utilities. So there's some notions of independence there. We are also using market concepts, so procurements, to operationalize the project. We're doing a distribution non-wires, and we're using energy auctions, capacity auctions, and reserve auctions to manage that at the distribution level, and also the coordination with the wholesale market. We don't have time to get into the details of this, but this is an ongoing thing. We're running the energy auctions right now. We ran a local capacity auction last year. We're running the energy auctions right now. And we're introducing for the first, we didn't have it this past summer, but in the next go around of the demonstration, we're introducing reserve auctions, local reserve auctions into the demonstration. And towards the end of next year, we're sort of going to wrap up the demonstration with some lessons learned reporting and some modeling work as well. And I'm not going to speak to all of these details here. I'm just going to skip to research gaps. So this is from, I guess, from our perspective. There needs to be some more work probably around sort of aggregations and how to model that, in particular heterogeneous aggregations. So that means that there could be an aggregation of DER that's comprised of solar, batteries, storage, smart thermostats, all sorts of things. And how do you really model that, and how do you treat that in the markets? I mentioned multi-node aggregations, so aggregations that span several transmission nodes. How do you deal with that? Multiple services. So if a DER is providing services to the host load customer, or the distributor or the ISO in the wholesale market, how do you manage that? What are the rules, again, around double counting, double compensation, conflicting instructions, especially when you're relying on the DER for services? We have to make sure that we get all of that right. And then finally, we're getting into the details of things as well, like with respect to distribution losses, like we spoke to, but also more complex distribution networks or even sub-transmission networks. How do you capture that? So if there's radial distribution lines, is easy enough to sort of manage, I suppose. But if there's a networked distribution system where the output of the DER could pop up on the transmission level, in potentially several places, depending on the load flows at the distribution level, how do you capture that at the transmission level? How does the ISO have a little bit of visibility into if a DER is dispatched, where to expect that output to come up. And then final slide here, just note that we have quite a bit of material online, and so does the OEB. So just a few links here for folks that have interest. And with that,
thank you very much, Ali, and thanks for taking questions while you were making a presentation, trying to make it a bit more dynamic. So I'm going to open the floor for the the floor for questions. So I start. Valeria had a had a question.
Yes, thank you very much. Can you hear me?
Yes. Hi, Valeria.
Okay, thank you. Hi. Yeah, I have, well, some few questions. The first one, it's a little bit more, let's say, technical. You were talking about, well, I mean, what I understood is there are these two different approaches, right? About distributed resources and how to have this integration into the market. I mean, some of them you can integrate, aggregate them, and they can even respond to instructions of the ISO, but some of them, they will be like so small and so many that it would be impossible, right? So, well, I mean, ISO has ISOs all over the world. I'm from Mexico. Well, it's useful. Usually they have control over everything, right? So, I mean, having this situation of them losing this control somehow and maybe having this more active DSO, I mean, that's going to be like a huge impact, right? And maybe thinking on one of your first slides when you talked about not having any benefits on reliability. Yeah. I mean, maybe if with enough regulation or with enough policies, you can help, well, ISOs or even at a utility scale to see these. That is, there is actually could be an increase in reliability.
Sure, Valeria. Can you get to your question, please?
Yes, I mean, how to make the ISO think, well, see this as not a detriment, but an increase in reliability.
Yeah. So Valeria, I mean, many good points there, and the question is really good. And I just want to be clear that we don't, I don't think the ISO sees DER as a problem. And we're in fact looking at DER as a potential resource that's going to be helpful to us. So in terms of reliability, as long as the DER are properly integrated into our wholesale market, and all the good things that you need for that, right? Like in terms of non-performance charges, in terms of just having a capacity auction where there's an enrollment process, so we have visibility into who's participating and all of that. And then very importantly, the actual performance of the DER and like the historical sort of data that we have around the performance of DER, all of those things sort of contribute to making sure that we can deal with DER in a sort of reliable way. I just want to maybe reiterate that, you know, that diagram from MIT, I mean, it's not my diagram, it's those folks, and you guys sort of honed in on the sort of reliability aspect of it and noted very, you know, aptly that they didn't have a lot of, or had zero value with respect to that. I think that has to do with the distribution level sort of resiliency value. Again, like if there is an outage, can the DER help the customers in that local area? Not necessarily from a transmission perspective. The transmission perspective is already captured in this right here, right? The energy value at the transmission level, right? And that sort of non-wires bit, which could be transmission non-wires. It could be transmission infrastructure that's being deferred or avoided, or it could be distribution infrastructure that's being avoided. But if it's at the transmission level, then again, that's sort of transmission level value that we're sort of recognizing that the DER could provide. So hopefully that's somewhat helpful. Did I answer your question, Valerie? Yeah.
Yes, thank you very much. I don't know if I can ask another one or just wait if someone else has.
Sure. Can you identify yourself?
Oh, you can see me?
No.
That's just Valerie.
Yeah, you can see you, but you are Valeria, and you work where and where you come from?
Oh, yes, I'm sorry. I was focused on the question. Yes, my name is Valeria Amezcua, and I work at the Energy Regulatory Commission of Mexico. So, well, personally, I've been very interested in theirs topics, and well, also we have been developing some regulation on the matters. We've always had a lot of problems with the distributed generation. That's also was the reason of my question. That sometimes there's this rule of thumb that it has benefits to the grid, and we know it does, but it's never really quantified because it's very difficult to do so, right? So it's like this difficulty that sometimes we find here, sometimes with the ISO or with transmission or distribution, that they are like they kind of don't like this change because they really don't understand the benefits. So it's kind of difficult sometimes. And also, well, like this idea of having all this pricing, as you said, it's very, well, it's more expensive to have distributed resources, and this locational value, well, it's also like kind of difficult to measure, right? And sometimes
sure, but keep in mind that these are markets under development, right? So it's early in the game. So there are issues and there are things being developed. I guess Ali is presenting examples of them, but these things have not been fully addressed, right? We are working on how to figure these out, right?
Yeah.
So,
and Valeria, and Valeria and Professor Canizares, like, I mean, it may be challenging to put numbers on these things, but people are. And like, you know, for instance, in New York and California, and maybe I'll just note this, like for instance, New York has, has a cost-benefit analysis framework specifically to put a number on the value of DER. And we in Ontario do similar planning assessments where we look at DER at the transmission level because it's ISO, but at the transmission level, we look at the cost of DER versus alternatives. So when we do planning, we look at many different solutions. We don't look at one thing. We look at different types of things combined together in various solutions. And we do economic assessments around that and make recommendations in terms of how to proceed with that. So it's very, like, as hard as it is to put numbers on these things, everybody is working towards it, and many are very much putting numbers on, to the value.
Okay, thank you, Valerie. So I guess we have run out of time, so I don't see any other hands raised. Just had a quick question regarding the ISO. Final question. Taking delivery as the guest here is the question of how many in that example you guys are working with Electra, that
yes
project you're working with Electra. How many people are participating in it?
Yes, yeah, I actually have a slide on that, Professor. Oh, found it very quickly. So we ran our first, so we're running 2 local capacity auctions. Each capacity auction has a commitment period associated with it where we run local energy auctions. So we ran one in November of last year. We were seeking 10 megawatts. We have 34 megawatts registered, and we have 7 participants. Several of them are aggregators. And interestingly, Energy Hub, which is at the top of the list there, is a smart thermostat aggregator. And so there's grocery stores, there's energy, there's quite a bit of participation. There's 7 of them. And in the second, we're going to run another local capacity auction in a month or in a few weeks. And we're bumping up our number to 15 megawatts that we're seeking. And so we're going to be rerunning this process.
So these are capacity markets.
This is, yes. So in our demonstration, we have 3. It's Nonwires, which, EPRI sort of defines as, unfortunately, I think, EPRI defines, my apologies, I'm just like flipping through these. I do want to show you. Okay. So EPRI defines distribution capacity as one service. In our demonstration, we're breaking that up into 3 services. So there's capacity, energy, and reserves. So we're running 3 different auctions, including, to your point, Professor, a capacity auction, a local capacity auction. Only the distribution connected DER that are below that constraint that we're trying to address, only they can participate.
You're running this through Electra?
Yes, yes.
Okay.
So it's a project that we initiated, and we were very much involved in the design of it, but it's Electra that is running it. And,
Okay.
I mean, it's my project, and I'm so interested in it. But yeah,
fair enough.
Yeah.
I appreciate that.
Yeah.
Thanks for the explanation. Thanks for the presentation. Thank you very much, Ali.
Of course.
Really appreciate it. Thanks for your time. Thanks for those of you who attended and your questions. I guess all of these are going to be recorded, so you might get more questions
Yes.
through email. I guess we'll provide that alternative. There's somebody raised his hand. Xiao Yu Wu. Maybe a last question here. Go ahead.
Oh, no, I was just clapping my hands.
Oh,
All right.
Thank you so much for the talk.
of
Okay.
course.
Thank you.
Of course. My pleasure.
Thanks, Ali. Okay. Thank you very much, and thanks
Thank
for
you,
all of
everyone.
you who attended. Hope to see you in the next seminar. Thanks, Ali.
Thanks. Bye-bye.
Bye for now.